smartphone, makikita ko ba yon?
Magdodoble eh. Kasi
Ah,
ginagamit ng camera mo yung ano eh, yung WebEx eh.
Ay, ganon. Ay, oo nga pala, no? Lo, nagdodoble, no? Ay, okay na.
I'm audible.
In your WhatsApp. Please join. In hall 4. That is in hall 4.
I'm audible, right?
Yes.
Yeah. A very good morning, good afternoon, and good evening, all present here. I have welcome all of you to this patient session 4 for the clients. Myself, Tuli Roy Chaudhary, on behalf of IconSWM and other partner organizations, welcome all to this patient session 4 for the clients. It's an honor having among us session chair Dr. Arturo Mario I. Figorio, Program Coordinator of Holy Angel University, Philippines, and co-chair Dr. Aris O. Ativo, Research Director at CBSUA, Philippines. I would like to remind a few points to all present here. All the participants are requested to mute microphone and close camera. Speakers may be unmuted only when requested. Please adhere to the presentation duration of 12 minutes for the speaker to avoid tealing. Question answers will be at the end of the session. Questions should be written in the chat box to the specific speakers. The chairs individually will rate the presentation on the rating sheet provided to you. Chairs kindly write the chair summary of the session with a few key outcomes and present at the end of the session. Fill the rating sheet of the chair's summary and please send us to the mail ID provided to you. I request all the presenters to kindly confirm their attendance in the chat box. Please make a note. I repeat all the presenters to kindly confirm their attendance in the chat box. I request our chair now to kindly start the session. So, hello. Dr. Figurio, so are you there?
Yeah.
Yeah. You can start, sir.
My presentation?
No. You are chair, right?
Yeah. Okay.
Yeah.
Good afternoon here in the Philippines. Welcome to the special session for the Philippines. And today we are about to present to you under the sessions about 10 scientific papers. My co-chair in this session is Dr. Aris Atibo. Dr. Aris, can you open your so that they can see you? Okay, so this is my co-chair, and uh, as we start, we call Dr. Naperi, the president of the CBSUA, to give us the opening remarks. Take it away. Hello?
Yes, sir. We can see something, but it's not playing.
Yeah.
Yep, it's not playing. Wait.
Something wrong, Aris?
It's playing on our part, but it doesn't show here. Wait, let me check again.
Share screen? Alright, okay.
Share has been stopped.
Audio,
It's not.
the audio? Audio.
No. I'm not able to hear. Dr. Piquerio,
Yes?
we are not able to hear
Me
Professor
also.
Naperi. His audio is not clear to us.
Yeah, maybe they have some technical problem in the university.
Okay.
Aris, may I call on Aris? Okay, maybe they
They
are.
are trying. They are trying to. Yeah. Let's see. Uh, Can they send their presentation? We from our end may try. Are they trying to play a video of Professor Naperi? Or is he present physically? Do you know, Professor Dr. Figuerio?
The Dr. Naperi is not around. He just prepared a pre-recorded
Video.
video. And do you think they have to send the video to you, or I don't know. I don't know the technicality.
No. There is some problem. There's no problem with playing the video, but we can see Professor Naperi, but we can't hear him.
Yeah, me also. I cannot hear.
Uh,
Uh, Dr. Aris, are you there?
Yeah, we are hearing the audio on our part. I don't know why it's not presenting itself in WebEx.
So there is a incompatibility.
I probably
Yeah,
because we're
so
not we don't use WebEx here, but
not WebEx. Okay, Aris, maybe we can move forward, and then
yes, please.
uh, for formality, the chair is the speaker number one for the paper. Could you please introduce me?
yeah. First.
for formality, Dr. Aris, can you introduce?
Yeah, Dr. Figueroa, our first paper presentation is headed by.
Can
It
you
will be
open
presented
your
by Dr.
video?
Yes, sure.
Okay, okay. So can you
Yeah.
introduce me?
Good afternoon. Good afternoon, everyone. Our first presenter will be from the Philippines, and it will be from Dr. Figueroa and Lile Pintor. Okay. Dr. Figueroa is a retiree. He's a retired professor. So without further ado, so I think Dr. Figueroa, you will be the one to play it.
Yes, yes.
Okay.
Okay, good afternoon to all participants in this special session and also to those who in other countries listening to this uh, presentation. Okay. The title of the paper presented to the 11th IconSW is Elementary Method for Low Process Heat Recovery for Organic for organic from organic waste processing as complement to circular economy. Okay, uh, to, to, to begin with, we have this literature review surrounding this study. First, there are a list of researchers whom I have met, whom I encountered. For example, Caparino in 2018, he said that in the Philippines, the previous researchers are concentrated in direct combustion, carbonization, densification, and biogasification of organic waste. They call this direct fuel type. However, not so much study in non-NFT, non-fuel type process heat is done. So this is why I came in. Moving forward, other researchers like Myers et al. 2018, Varga and Palantir 2017, according to them, there are plenty of studies in low process heat by solar heating, in space heating, applied in space heating, washing, cleaning, but not from organic waste. Here, the centerpiece of the study is the process heat from organic waste. And then Rastogi et al., Rarigonia, and Tristakti and Sailani, these scientists said that people, they observe temperature recording in organic waste composting. Okay. This is my experimental setup. The essence of my study is I invented a miniature model of a sanitary landfill of organic waste. It is a miniature model. These are the physical parameters, the volume, the width, the length, the height, the inner wall, the covering, the outer wall, and then the insulation, and then the drain pipe, and specific parameters. And then the organic waste content, compacted organic waste, dried leaves and shells from mahogany. And these are sandwiched between two soil layers, okay? And then another parameter in the setup is the heat absorber. It is a 15-meter long copper tube, and it was designed like a snake, no? And then the volume of water in copper tube at any given time, and all the parameters that I use, the flow rate, etc. No? And then the experimental activity is temperature recordings, daytime, nighttime, 27 days as or 1 month, more or less 1 month observation. And then this is the schematic diagram of the sanitary landfill model. You see there is a upper soil layer compacted, and then in the middle the compacted organic, and then at the bottom is the compacted soil. No, it is inside this compartment. Okay, and then this is in the center of the sanitary landfill model, there is a heat absorber. a 15-meter long copper tubing was designed like this in a form of serpentine, and then it is embedded in a copper plate as additional heat absorber. Okay. And then the experimental result. You can see the temperature growth profile of the water coming out from the system for a period of 1 month. You can see we were able to at least reach or arrive at nearly half of the boiling point of water. So this is the more or less you can feel the temperature of the water that came out from the system. And this is the temperature of the water outside the system. So to compare the validity of my findings, I compare it to other researchers, in especially those who are researching in composting activity, like Reed et al. So more or less, my data is the red one, the foreign one is the yellow one, and more or less there is a comparability. There are compatibility in as far as the result of the temperature findings in the composition of the organic waste. And then this is the state of the waste after 1 month, after 27 days of observation. You can see that there is not much decomposition of the compacted organic waste. You can see this is the heat exchanger. And then the final objective of the paper is the heat recovery in 1 month. I use area under the curve method, complemented by analytic heat transfer equation. And then this is my measurement. The temperature for the water curve by graphical method. I was able to harvest 112,000 Kelvin hour, and then compared to the temperature curve out by graphical, and then I was able to harvest 97,844 Kelvin hour, and the computed heat recovery in 1 month or 27 days, incorporating all the parameters in the experimental for the analytic equation. I was able to compute an average of 80,000 joules per cubic meter of the model per day. So to conclude this study, my conclusion in my study are the following. The low process heat recovery, nearly half boiling point of water, is feasible in the invented sanitary landfill model. Secondly, it is a promising co-processing method in actual waste disposal facilities. And lastly, if you scale up the model, more or less, you can harvest practical energy magnitude in a real sanitary landfill using the approximate index that I was able to compute. That is, and thank you for your kind attention in listening to this first paper in the Philippine session. Okay. Okay, that finishes the paper number 1. Okay. To continue the special session for the Philippines, I will get the attention of the next speaker, number 2, headed by Dr. Aris Atibo from the Philippines. The title of the paper from the Central Bicol State University of Agriculture is A Review of Climatic Trends and Slow Onset Events Associated with Climate Change, the Impacts to Agriculture in the Bicol Region, Philippines. Take it away, Dr. Atibo. Dr.
They
Aris?
will play it. Yeah, they will play it because they are pre-recorded video. Amy and okay.
Audio
Aris, the audio.
thing in the recorded portion, the audio is not coming.
We're actually checking it. What could be the problem? Because on our part, it's playing with audio, and we have all the pre-recorded video. So
Figueroa, can we move to the next speaker? By that time, he can check and play.
Yeah, okay. But my worry is that the presenter of the next is coming from the same university, and they are
Okay.
their presentation are in that kind of system with no audio.
Oh,
Anyway, moving forward,
okay.
may I skip from the UST uh, while Dr. Aris is Dr. Aris?
yes, sir.
Can I are you still uh, trying to improve the technicality of your presentation, or can I move to other presenters like UST?
Yeah, sure, no problem.
So, okay. Moving forward, may I call on Arlen Anchieta from the University of Santo Tomas to present the paper Plastic Flow Along Manila Bay, a case study of Barangay Baseco. Anybody from the co-author of Arlen Anchieta? Hello?
Hello, good afternoon, sir.
Yeah.
Dr. Arlen Acheta is not around.
So, who will present in behalf of Arlen Anchieta? Yeah.
Ma'am, I think she submitted a recorded video.
And where is the pre-recorded video? Dr. Goss,
Yes, yes.
we have a problem here of the pre-recorded video.
In fact, you know that pre-recorded video always gives problems. So that's why I told several times that send the PPT, PowerPoint presentation, and simply share the PowerPoint presentation. That is always better because of the network issue and all other things. I think it is a problem for you to share the video. So, however, Arlen, I mean, you all have the PowerPoint presentation, no? Hello?
Hello from
I'm-
UST, University.
Sorry, sir, I don't have the copy, but I could communicate with her to send me the PowerPoint.
Yeah, what I'll request you, please call all the speakers who are not here and ask them to send the PowerPoint presentation to your email and kindly share those from here. And how many presenters are present here today from the Philippines side?
Only me and Dr. Apueo who is going to give a live presentation. The rest are
Okay.
video recorded.
I submitted a recorded, I submitted a recorded video, but I could also present live.
Okay.
Yeah, very
From
good.
UST.
Okay, very good.
So, Figueroa,
Yes.
what I'll request you, please go ahead with the physical presentation of three. You,
I already
Rackwell.
presented. I'm already through.
All right. All right. So you go ahead with other two presentation. Meantime, you call all of them, whoever are here, to send their PPT presentation and prepare their PPT presentation so that they can make a PPT presentation. Otherwise, video presentation, I think that you have some problem, right?
Yes.
Where is Linley? Linley has joined or not?
Lily is not around.
Okay.
Okay.
Aris, yeah, Aris is there. Hello, Ativo Aris.
Yeah, Dr. Gosh. Yeah.
Yeah.
We
Good
have
afternoon.
can you allow the host? Can you allow
Yeah, no
SD to
problem.
share?
We are making you the host.
No,
Host
it's
or
actually ESD. There's the one present there.
EST. All right. We are
ESD.
making you co-host.
Yeah.
Oh, co-host is not allowed. No, 1 minute. Co-host
They
allowed.
he has
No, it
the
is not. It is
recorded videos.
one. Our computer to the open? Yeah, we are making you the co-host so that you can make those things. All right?
Yeah.
Is it okay?
Yeah, all right. Yes.
All right. All right.
Is it okay now?
Marvin of ESD,
No,
please share.
give us 1 minute. Our computer.
Okay, sure.
Huh? Yeah, you are now the co-host. Atif.
Are we going to wait for them or we will move forward? And
No, Figueroa, let us resolve the issue first.
okay.
Let us see whether he can do it or not.
Yes.
Aris,
ESD is already the co-host, so I think he's trying to.
yeah, just try once and see whether it is possible
Yes.
or not so that
Okay,
Figueroa can start.
ESD Marvin, please.
ESD is host.
Viewing ESD's screen still black. Marvin ESD already the co-host, so we're waiting for the PowerPoint. No, the pre-recorded video.
Good day. I will be presenting a review of climatic trends
Okay.
and events associated with climate change.
That's great. So
Impacts
it
of the
will
heat
work.
in the Bicol region
Yeah,
of the
very
Philippines.
good.
I am Aris
Figueroa,
Aquino,
you can
and with
start the
me is
proceedings.
Professor
Yes.
Arthur Estrella
Okay.
from
The
the
next
Central
speaker is
Philippines
Aris, Dr.
University of
Aris.
Agriculture. That's in the Philippines. To begin with, climate change is a global phenomenon. It involves changes in the usual temperature, rainfall, and wind patterns in a given place. One of the major climate-related phenomena of climate change is slow onset events, or the SOE. SOE are gradual decreasing or increasing changes of a climatic variable such as rainfall or temperature. This might have happened over a long period of time and has progressed with increasing intensity. Slow onset disasters advance and unfold over months or even years. This is the objectives or methods of the study. We determine the climatic trends and slow onset events relative to climate change and also establish associated impacts to agriculture. The study was located in the Bicol region. It is one of the administrative regions of the Philippines, as you can see in the map. Bicol is comprised of 6 provinces, 4 on the Bicol Peninsula mainland, and 2 islands provinces, such as the Catanduanes and the Masbate. The region is in typhoon belt and is often visited by strong storms, resulting to heavy damage to agriculture. Okay, let's proceed with climatic trends and SOEs, or the slow onset events. Let's begin with temperature. Based on our research, we found out that there is an increased temperature in the months of March, April, May, and June for the Camarines Norte and the province of Camarines Sur. The maximum temperature in these months would often reach a range of 35 degrees centigrade in a minimum temperature of 25 degrees centigrade. This coincides with the dry months, making the dry season extensively hot. It is also in these months that dry spells leading to drought have been observed to occur. These dry spells is most pronounced in the rain-fed agricultural areas. Dry spells leading to drought is considered a slow onset event. This figures only shows the climatological average temperature value in the 2 adjacent provinces of the Camarines Sur and Camarines Norte. Data shows that it is highly cooler in Camarines Sur than in Camarines Norte, as shown by the annual average minimum temperature. Okay, let's proceed to the projected seasonal temperatures. This shows that the projected seasonal changes in temperature, the median level, indicate that the provinces of Camarines Sur, Camarines Norte, and Sorsogon may be warmer by 1 degree centigrade by the mid 21st century. So this may indicate warmer days and dry spells leading to drought. Now let's talk about rainfall. Based on our research, it shows that rainfall in the parts of Camarines Norte are near normal levels, while the rainfall in Camarines Sur is below the normal levels. Areas in Camarines Sur may experience less precipitation and may affect production of crops that are sensitive to water stress. The Department of Agriculture in our region forecasts that rainfall to be similarly below normal levels in the range of 51 to 58% of normal in all six Bicol provinces. These figures shows the climatological normals of rainfall again in the two adjacent provinces of Camarines Norte and Camarines Sur. Data shows the similarity of rainfall relative to climate types and the climatological normal of which indicates more rainfall towards the last two quarters of the year. In Camarines Sur, an increase in precipitation is observed to start in the months of May to December, while Camarines Norte have more rain in the months of October to December. Camarines Norte also have more rainy days, 207 days, and Camarines Sur of only 165. This is evident in the low number of rainy days and the low rainfall in the dry season. Okay, so this one is the projected seasonal rainfall in our region, in the Bicol region. The projected seasonal changes in rainfall median level for RCP 4.5 for Camarines Sur, Camarines Norte, in the province of Sorsogon indicate a 10% seasonal changes in rainfall for all provinces. The changes will largely occur in the period of June to November. This may suggest that there may be a reduction of rainfall in Bicol and in the mid 21st century. So here are the associated SOE or slow onset event. First is the topographic nature of the Bicol River Basin, particularly in the lower floodplain, are exposed to the hydrometeorological hazards, which may be characterized as SOE. Rain results to floods or slow onset floods, while less rain results to dry spell or drought. The lower floodplain that include the municipalities of Nava, Bulam, Minalabak, San Fernando, Miloorgainsa, and parts of Camaligan, Kanawan, and portions of Naga City are most vulnerable to such events. The slow onset flood is attributed to the combined effect of the regular passage of typhoons, high runoff in the surrounding volcanic and sedimentary terrains, and the natural low elevation of the Bicol floodplain. These are affected by discharges from the upstream, the Bato and the Buhi lakes, and tidal fluctuation from San Miguel Bay. The tidal fluctuations brings more saline water intrusion to the area. Uh, in addition, the inflow of flood water from the upstream area is gradually slow, and the flood water that recedes and drains to San Miguel Bay through the Bicol River is also gradual and slow. As a consequence, the maximum duration of inundation is about 7 days in these areas. The maximum inundation depth of 2.5 meters is estimated in the areas adjacent to the Bicol River. On the other hand, these areas in the floodplain experience dry spells, often slowly leading to drought during dry months. Given such biophysical regime and climatic trends, the slow onset events in these areas of Bicol include slow onset floods, salinization, and dry spells leading to drought. So these are the impacts to agriculture. Agricultural crops, particularly rice, is very sensitive to water and temperature stress. Dry spells or heavy rainfall occurring immediately after seedlings are planted or seeds are sown cause the plants to die due to water or heat stress. Heavy rainfall leads to slow onset flooding. Less in rainfall leads to dry spells. This may all lead to crop failure. About 42,124 hectares of rice producing area in the Bicol River Basin is affected by SOE, particularly flooding with 1 in 5 year return period. This is expected to increase to 50,402 hectares or 16% of the area in a 1 in 25 return period of flooding. This data came from the Department of Environment Natural Resources report in 2015. Okay, lastly, I'd like to show you the impact chain diagram of this study. So with climate change actually results in changes in temperature and rainfall. So it can affect rainfall, so more rainfall during wet season, and it can also lead to less rainfall during dry season. And it also result to warmer days during dry season. So coupled with the rainfall variability, which is the wet and dry season, and the temperatures above normal during dry season, and coupled with the topographic relief of the Bicol floodplains. So here are the slow onset events that are prevalent in the area. So it will be the slow onset flooding, the dry spells, and the saline intrusion. And because of that, the impact to agriculture is very glaring. This will result to crop failure in rice production areas. And we all know that rice production is very important for us Filipinos. So with that, would like to thank everybody for listening. As we say it in the Philippines, maraming salamat po. Thank you.
Okay, thank you very much. Okay, thank you very much, Dr. Atibo. Moving forward, may I call the next presentation. This time from Eileen May Buffete, Jennifer Ivonia. The title of the paper is Utilization of Single-Use Plastics in the Fabrication of Concrete Hollow Blocks. May I call on the speaker on paper AB 223? Are you there? Eileen?
Yes, we will play it.
Okay, okay. So again, it is a video presentation.
Okay. ESD all is removed again as co-host. Can we request? Yeah, no, it's okay. It's still co-host. Okay, Marvin, please.
Good day, everyone. My name is Eileen Maybibo, researcher of utilization of single-use plastic waste in the fabrication of concrete hollow blocks from the Department of Agricultural and Biosystems Engineering. The Philippines is among the highest trash collection rates in the Southeast Asia, yet it's the world's third massive source of plastic leaking into the ocean, according to the Ocean Conservancy and Mackenzie Center for Business and Environment. Some have blamed this in our country's sachet economy or earthy culture, which has incentivized companies to sell their products in a single-use plastic and aluminum sachets instead of in bulk. It also appears that we lack the infrastructure to deal with the plastic waste, considering that we generate around 2.7 million tons of plastic waste annually. One of the solutions to this problem is recycling. However, not all solid waste is recycled. For instance, only 8.4% of the plastic waste is recycled in the Philippines. As the quantity of waste generated increases yearly, it is therefore vital to find ways to recycle this waste. This reality has motivated me to take up an initiative that repurposes single-use plastic waste from being polluted to an effective solution to the plastic waste problem. of the country. Single-use plastic waste is a residual waste. They are no commercial value. They can't even be sold to junk shops, but I saw their potential. I decided to turn single-use plastic waste into something useful. This study offers a method of recycling plastic waste in the form of additional aggregate to concrete masonry units called hollow blocks. Study aimed to test the physical and mechanical properties of the concrete hollow blocks with shredded single-use plastic waste, specifically the weight, termite resistance, compressive strength, absorption, and density. Compare the physical and mechanical properties of the concrete hollow blocks with and without shredded single-use plastic waste. Determine the proportion of single-use plastic waste which reaches the standard specification and concrete hollow blocks compared to standard concrete hollow blocks. And lastly, determine the economic viability of the fabricated concrete hollow blocks. This study is significant in the decline of environmental issue caused by plastic. It also reduces landfill sites, toxic leachate, and contaminates nearby stream, ponds, and lakes. It will be also significant to consumers and manufacturers. This study could bring about advancement in recycling technology in Bicol region, and at the same time, eye-opener for the government to invest in the recycling of waste and thereby make an appropriate legislation coupled with incentive to encourage the general public to participate in recycling. And it will also bring about the development of solid waste management, considering utilization of single-use plastic waste as additional aggregate in the concrete hollow blocks, thereby solving the environmental and economic impact associated with its disposal. This kind of single-use plastic waste that were non-degradable can be a resource in the construction industry, or a solution for solid waste problem, and a green alternative to concrete hollow blocks. The material used in the study were 12 kilograms of shredded single-use plastic waste, 2 bags of Portland cement, 1 cubic meter of ordinary sand, and water. The experiment was composed of 4 treatments and 4 replicates each. The proportion of materials were on a volume basis. For the control hollow blocks, the water to cement ratio was set at 0.5 and the sand to cement ratio was 1:7 as per structural engineer's specification. For the experimental hollow blocks, 1 part, 2 parts, and 3 parts by volume of the shredded single-use plastic waste added were shown in Table 1. The experimental procedure in this study was the collection of single-use plastic waste, shredding, preparation, mixing, molding, drying, curing, in the concrete hollow blocks, and testing. To compare the profitability of the production of the concrete hollow blocks with shredded single-use plastic waste to existing concrete hollow block ventures, cost and return analysis and partial budget analysis was employed. The comparison of physical and mechanical tests with and without shredded single-use plastic waste was shown in presentation. The data showed that the T1 has the greatest mean weight of 9.73 kg, followed by T4, T2, and T3. Therefore, the addition of shredded single-use plastic waste in the concrete hollow blocks can reduce the total design load. The compressive strength for each concrete hollow block per treatment was examined under the applicable ASTM-C 140 method in the EV Testing Center at San Felipe, Naga City under the ASTM-C 90 standard specification for load-bearing concrete masonry units. T1 and T2 obtained the standard compressive strength of 4.14 MPa, while T3 and T4 did not reach the required compressive strength. Therefore, the addition of 2 kilograms of shredded single-use plastic waste was feasible to utilize on the admixture of the concrete hollow blocks. After 1 month of observation in the termite field test, the data shows all the treatment have tolerance against termite. The table shows the mean absorption of the concrete hollow blocks where T4 obtained the highest mean absorption of 373.30 kg per cubic meter compared to all other treatments. Table 3 followed the mean absorption of 247.82 kg per cubic meter was not significantly different to T2 with 239.73 kg per cubic meter, and T1 the lowest mean absorption of 228.54 kg per cubic meter. Under the ASTM-C 90 standard specification, T1 and T2 obtained the standard requirement for the maximum absorption of 240 kg per cubic meter, while T3 and T4 did not exceed the required amount. This indicates that the lower the absorption, the better the result. Therefore, T2 with 2 kilograms of shredded single-use plastic waste has a reduced absorption rate in the same as the concrete hollow blocks without shredded single-use plastic waste. The data shows T1 has the highest density with 1,953.36 kg per cubic meter, followed by T4, T2, and T3. Under the ASTM-C 90 standard specification, all treatments obtain the standard requirement for the density range of 1,680 to less than 2,000 kg per cubic meter. Therefore, adding shredded single-use plastic waste in the concrete hollow blocks was feasible to obtain the standard requirement for the block density. T1 obtained the highest mean porosity of 1,265 nanokilogram per cubic meter, followed by the T3, T2, and T4. The analysis showed that the increasing ratio of the shredded single-use plastic waste has significantly different from each other. Therefore, as amount of the shredded single-use plastic waste increases, the porosity of the concrete hollow blocks decreases. T1 is more durable for all treatments, but T2 with 2 kilograms of shredded single-use plastic waste was feasible to conform the physical and mechanical requirements prescribed on the ASTM-C 90 standard specification for load-bearing concrete masonry units. The partial budget analysis of concrete hollow blocks shows that the addition of shredded single-use plastic waste would increase the income of 12,500 per year, shown in the Table 8. There would be no difference between the returns of the two mixtures since they are priced equally with the same volume of production. Furthermore, addition of shredded single-use plastic waste would decrease the production cost since one of the raw materials is a waste byproduct. Using the cost and return analysis shown in Table 9, concrete hollow blocks with shredded single-use plastic waste were economically viable. As you can see, the concrete hollow blocks with and without shredded single-use plastic waste has the same total income of 1,716,000, but in the concrete hollow blocks with shredded single-use plastic waste has a higher amount of total fixed cost and a lower amount of total cost compared to concrete hollow blocks without shredded single-use plastic waste. The utilization of single-use plastic waste production will generate income higher than the return of concrete hollow blocks without shredded single-use plastic waste ventures. The basic assumption and data used in the economic analysis were shown in Appendix E. After summarizing and analyzing the data, the following conclusions were made. The comparison of testing parameters of the concrete hollow blocks showed that the T1 or control has the heaviest weight compared to all treatments. As the proportion of shredded single-use plastic waste increases, compressive absorption density and porosity decrease. All treatments of concrete hollow blocks has tolerance against termite. Under the ASTM-C 90 standard specification for load-bearing concrete masonry units, T1 and T2 reach the standard requirement for maximum compressive absorption and density range of 4.14 MPa to 140 kg per cubic meter and 1,680 to less than 2,000 kg per cubic meter respectively. The production of concrete hollow blocks with shredded single-use plastic waste an aggregate is economically viable and will be more profitable than the concrete hollow blocks without shredded single-use plastic waste. From the result of this study, the following recommendation can be applied to maintain the quality of the concrete hollow blocks with shredded single-use plastic waste. Number 1, mix and molding of concrete hollow blocks may be done mechanically. The replacement of sand by shredded single-use plastic waste could be as high or lower as 2 kilograms to determine the optimum proportion that would give the highest strength. Concrete hollow blocks shall be tested using the different sizes of shredded single-use plastic waste to determine the best quality in the concrete hollow blocks. And lastly, to acquire the most accurate result, evaluate the concrete hollow blocks at 56 or 96 days rather than the early stage of 28 days. Before I end this presentation, I would like to take this opportunity to acknowledge the Solid Waste Management Office, Naga City, headed by Engineer Joel P. Martin, and to my thesis advisor, Dr. Jennifer Erbonia, for awarded thesis support to my research, and they are the first adopters of this study to use concrete hollow blocks with shredded single-use plastic waste in their construction project in Naga City Aeropark. As a future agricultural and biosystems engineer, it is our task to change and improve engineering construction material to pass on a cleaner environment as we complete the circle of life one with nature. So be a change. Thank you.
Doc Fig, you're on mute.
Aileen, kindly unshare your presentation. Moving forward, our next speaker, which is speaker number 4, it is a paper AB 220 entitled Plastic Flow Along Manila Bay, Case Study of Barangay Baseco. This will be presented by the group of Arlen Cheta et al. Again, I think it is also a video recording. Dr. Aris, anybody from the group of Arlen Cheta?
Yes, we're
I
working.
think she, sirs, ayan.
Good morning. The title of our presentation is Plastic Flow Along Manila Bay, Barangay Baseco in Context. I am Arlen Cheta. Together with me are Doctors Moises Norman Garcia and Maria Rosario Virginia C. Garcia, as well as Assistant Professor Ronald Castillo. We are from the University of Santo Tomas. For introduction, our study site is the Manila Bay, and the Manila Bay has been a very controversial body of water in the Philippines. It has been a battleground during the colonial period and still a battleground post-colonial period because of pollution. Manila Bay has been an important battleground during the colonial period. At present, the bay is still a battleground and facing another threat. As a transboundary resource, this historic site is vulnerable to plastic pollution caused mainly by human activities. There is urgent need to address this environmental problem in support of marine-based food security for the future generations and attain most of the United Nations Sustainable Development Goals come 2030. The objectives of the study is to generally understand the plastic material balance flow along the Manila Bay, and specifically to construct a scheme of locally made plastics and single-use plastics flowing in Baseco up to the Manila Bay, to establish flow pathways on how plastics could enter the Manila Bay. The study is significant as it provides single-use plastic material and balanced flow model generated in the barangay and disposed in the Manila Bay. The model crafted from the study could serve as a tool that can be used by policymakers and implementers in reviewing existing policies and ordinances on solid waste management, marine protection, and disaster risk management. The theoretical framework is based on the law of conservation. That is, equal signs are placed between the numbered boxes, which means that the mass of the plastics entering the barangay is equal to the mass of the plastics being consumed in the barangay, which is also equal to the mass of the same plastic material disposed or outflow from the barangay. Our methods are quantitative and qualitative approaches. Our study site, map of the Manila Bay, is a body of water surrounded by 5 major regions. the Manila Bay is almost completely landlocked. It is considered one of the world's great harbors and has an area of 770 square miles circumference. The study site specifically is the locality of Baseco along the Manila Bay in the city of Manila. Its population, as determined by the 2015 census, was 59,847, representing 89.67% of the total population in the city of Manila. The methods of gathering data are Zoom interview of key informants, content analysis of secondary data, and visual presentations. Now, the study used mixed method approach, but for this presentation, qualitative methods is being highlighted. The study is designed to investigate the plastic material balance flow along the Bay Area. The quantitative part is based mainly on the accounting methodology anchored on the principle of conservation of mass. On the other hand, the study used qualitative methods to provide data from end users using virtual interviews, the purpose of which is to support gathered quantitative data. The results and discussions. So these are the different single-use plastics that were studied in the barangay. And as I will show again the theoretical framework, and so there are 3 boxes: 1, entering the barangay; 2, consumption in the barangay; and 3, outflow from the barangay. And so this is now the result of the study. So we were able to identify 3 major components. 1, the entering into the barangay by production and distribution, as well as marketing of the single-use plastics. And then consumption in the barangay would mean the single-use plastics being bought and used by the households, as well as disposed in different manner. And then the third component, which is outflow from the barangay, would mean flowing into the Manila Bay, or they're going into the material recovery facility. And so this scheme, this overall scheme of plastic flow is a major result of our study. The study uncovers the garbage in, garbage outflow by tracing how waste is generated, processed, then flows out from the area to the Manila Bay. The plastic material balance flow studies articulate the law of conservation of mass as shown in the previous figure that I have presented. The mass of the plastics produced and imported into the barangay study site is equal to the mass of the plastics to be marketed and consumed, which is also equal to the mass of the same plastic material disposed both for recycling and residuals. Flow pathways. So the waterway pathways on how single-use plastics could possibly enter the Manila Bay. So this is the Barangay Baseco, and Barangay Baseco is strategically located at the mouth of a river, which is the Pasig River, and the Manila Bay. And then on the other side is still part of the Manila Bay, which is the port area. And so the single-use plastics in Baseco could enter through the Pasig River and through the port area on the other side. And improper management of waste disposal is a major factor that would lead to the outflow of single-use plastics into the Bay Area. So Baseco is bordered by the bay to the west and adjacent to the mouth of the Pasig River to the northwest, which drains into the bay as shown in the previous slide. Thus, without proper waste management, the barangay residents could dispose waste into the Pasig River or directly into the bay itself. Conclusion. The study was able to assess the plastic pollution along the Manila Bay based on the plastic material balance law and flow pathway. These models can be utilized by policymakers in aid of legislation on plastic waste. Thank you for listening.
Okay. Thank you very much, Dr. Ancheta, for that nice presentation. Moving forward, I will call the next speaker, number 5, paper number AB 193. The title of the paper is Social Implications of Plastic Pollution Mitigation Initiatives Along Imus River. Again, the authors for this paper are Maria Aguilar, E.C. Cabrera, E.F. Lineses, J.L. Morta, and J.A.R. Rosina. They all come from the Philippines, of course. Okay. Okay. May we listen to the and hear the video recording of this paper? Eileen? Dr. Aris?
Yes,
Are you in charge of this paper, number 6? Number 5?
we're checking.
Paper number 5, also pre-recorded.
So if the video is not with us, then we can proceed to the next paper, sir. No problem.
Okay. Moving forward, the next speaker, speaker number 5, paper number AB 221. The title is A Study on the Factors Influencing Disaster Resiliency, Barangay San Vicente, Laur, Nueva Ecija in Context. The researchers are Raquel Laico, M.R. Virginia Cobar Garcia, M.N.Z. Garcia. I think Raquel is around. Raquel?
Yes, sir.
Okay, go ahead. Are you okay, Raquel, with your
I'm having difficulty of sharing my file.
uh-huh.
If you have any difficulty in sharing your file, then I can send my mail ID so that you can share me. So can after that I can present for you.
But also I submitted a video, sir.
Okay.
Dr. Aris, the video, are you responsible for the video play? Dr. Aris? Okay. Okay.
It's coming.
Could you see my video?
Yes,
Just
yes,
see
yes,
my
yes.
PowerPoint.
Yes. Very good.
Good afternoon to everyone. It's an honor and privilege to be participating in this 11th International Conference on Sustainable Waste Management and Circular Economy. I will be presenting the research on a study on the factors influencing disaster resiliency, Barangay San Vicente, Laur, Nueva Ecija in context. My co-authors are Dr. Moises Norman C. Garcia, Dr. Maria Rosaria Virginia Cubar Garcia, and yours truly, Raquel C. Laico. According to the United Nations Disaster Risk Reduction in 2019, the Philippines is ranked third in the world as most disaster-prone countries in the world. The country was identified as a natural disaster hotspot with approximately 50.3% of its total area and 81.3% of its population vulnerable to natural disasters. Millions of Filipinos had been badly affected by natural disasters such as typhoons and earthquakes. The research would provide the significant information and a working model as to how a rural barangay like San Vicente in Laur, Nueva Ecija in the Philippines survive as a community after a catastrophic typhoon in 2015 in terms of resiliency during and after a natural disaster such as flash flood and landslide. The overall aim of the study is to investigate the factors that would influence the residents' disaster resiliency on past and future disaster, focusing on demography, perception of disaster, disaster awareness, and preparedness, collectivism, and political pressure. The hypothesized model of the study with this research hypothesis, demography, perception of disaster, awareness and preparedness, collectivism, political pressure significantly influence resiliency on past and future disaster. This is a quantitative descriptive correlational study using purposive sampling of household heads participated by 18 years old and above residents of Barangay San Vicente, Laur, Nueva Ecija in the Philippines. A total of 331 respondents accomplished the questionnaires. The table shows the multiple regression of age, gender, civil status, education, salary, type of house ownership, number of house members, number of children and elders with resiliency on past disaster. The research reveals that age, gender, and house ownership negatively predicted resiliency on past disaster, whereas the rest of the variables have non-significant effect on resiliency on past disaster. As the resident's age increases by a year, resiliency in past disaster decreases by 0.071. Hence, the older the respondents, the lesser the resiliency on past disaster. While gender increases by 1, resiliency on past disaster decreases by 0.287. Thus, female is less resilient on past disaster. Moreover, the greater the female population, the lesser the resiliency on past disaster of the community. In the case of house ownership, as it increases by 1, the resiliency on past disaster decreases by 0.134. That is, as the residence becomes a tenant or share the house, the resiliency on past disaster decreases. Thus, house ownership increases resiliency. The table shows the multiple regression of perception of disaster, possibility of disaster, floods, drought, strong typhoon, and landslide with resiliency on past disaster. Perception of the possibility of floods positively predicted resiliency on past disaster, while perception on the rest of the disasters have non-significant effect on resiliency on past disaster. As the residents' perception of the possibility of floods increases by 1, resiliency on past disaster increases by 0.325. The perception of the possibility of floods increases resiliency on past disasters. The table shows the multiple regression of the perception of disaster, the worriedness on the earthquake, floods, drought, strong typhoon, and landslide with resiliency on past disaster. The research shows that fear of floods positively predicted resiliency on past disaster, while the rest of the residents have non-significant effect on the resiliency on the past disaster. In the case of the residents' fear of floods, as it increases by 1, resiliency on past disaster increases by 508. Hence, as the fear of floods increases, resiliency on past disaster increases. The table shows the multiple regression of disaster resiliency, disaster awareness and preparedness, disaster management of earthquake, floods, drought, strong typhoon, and landslide with resiliency on future disaster. The findings revealed that information about disaster management and strong typhoon negatively predicted resiliency on past disaster. However, information about disaster management on the rest of the disasters have non-significant effect on resiliency on past disaster. As the residents' information about disaster management and strong typhoon increases by 1, resiliency on past disaster decreases by 0.152. Low resiliency on past disaster may be due to reduced recovery from the previous disasters. The table shows the multiple regression of disaster awareness and preparedness, preparation of emergency supply variables with resiliency and past disaster. The research reveals that batteries and cell phone and power banks negatively predicted resiliency and past disaster, and the rest of the variables have non-significant effect on resiliency and past disaster. As the residents' preparation of batteries and cell phone with power banks increases by 1, resiliency in past disaster decreases by 0.190. Thus, low resiliency on past disaster may be affected by non-preparation of batteries and cell phone for N power banks. The table shows the multiple regression of disaster awareness and preparedness, preparation of emergency supply variables with resiliency on future disaster. The findings reveal that preparation of batteries and cell phone with power banks and money for spending positively predicted resiliency on future disaster, and the rest of the variables have non-significant effect on resiliency on future disaster. As the residents' preparation of batteries and cell phone with power banks increases by 1, resiliency on future disaster increases by 0.140. While the residents' preparation of money for spending increases by 1, resiliency on future disaster increases by 0.0113. As a result, resiliency on future disaster increases when batteries and cell phone with power banks and money that are ready for emergency use are prepared. The table shows that multiple regression of community and family collectivism variables with resiliency and future disaster. The findings reveal that community collectivism, I'm happy as I work with my community members, negatively predicted resiliency and future disaster, whereas the rest of the variables have non-significant effect on resiliency and future disaster. Also, when the residents' community collectivism increases by 1, resiliency and past disaster decreases by 0.196. The result shows that the residents are more family-oriented, and this could explain their low resiliency when dealing with the community members. Conclusion: age, gender, type of house ownership, perception of disaster, disaster awareness and preparedness affected resiliency on past disaster. Resiliency on future disaster affected community collectivism and disaster awareness and preparedness. Political pressure by the local government unit has not affected the resiliency on past and future disaster. Recommendations. The residents' disaster resiliency in the community can be enhanced by the national government and LGU by strengthening the implementation of the Philippine Disaster Risk Reduction Management Act of 2010, also known as the RA 10121. The local government unit should prioritize disaster preparedness. This is possible by giving extensive seminars and trainings regarding disaster awareness and preparedness. The Department of Education should also play a great role in the implementation of disaster resiliency in the community. It is also important to make disaster risk reduction topics comprehensive, such as it would be integrated in the different courses. These are my references. I would like to acknowledge the University of Santo Tomas and the UST Research Center for Social Sciences and Education for making this study possible. Let me end the presentation with a quote: "We cannot stop natural disasters, but we can arm ourselves with knowledge. So many lives would not have to be lost if there was enough disaster preparedness." Thank you very much for listening.
Okay, thank you very much, Raquel. Again, moving forward, we now go to the next paper, number 7, paper AB 227, entitled Biochar from Corn Waste as a Biofilter in a Recirculating Aquaculture Systems. The researcher from Tarlac Agricultural University, Dr. Catherine D.R. Cuello. Okay, go ahead, Kat. Kat, your audio.
Am I? Oh, speaking right now, sir. I am speaking already, Doc. We can hear you. Carry on.
Can you hear Dr. Cuello?
There's no audio.
There is the audio.
Speaking, Doc. Try again. Ma'am, are you presenting the slide or you are just going to present it right now or you're showing the video?
Would you like to the video? We sent it to India. Would you like to present the video? Okay. Kindly, Dr. Goss, kindly present the video that was sent to you by email a while ago. Dr. Goss.
I couldn't get you, sir. Means that ma'am is presenting that thing or you are just showing the video, ma'am?
No, her video pre-recorded video was sent to
Okay.
Dr. Goss a while ago, so that we can just view that.
Okay, then I'm sending you my mail ID, so kindly just share in that mail ID.
Can I share? Can I try to share that video, that one that you sent me, Kat?
If you want to share, then I am just making you, sir.
Am I not audible?
This
Can
one?
you hear me now?
Yeah,
Can you hear me?
We can hear you now.
Yes, you can.
Yeah. Can I try again?
Yeah, you can.
What about this? I will cancel this.
No. You do not need to cancel, sir. Yeah, the video, something's you have screen share, right? You
Yeah,
share the screen.
Kathy, can I share the video pre-recorded?
Yes, sir. But can I hear now? Am I
Yeah,
audible now?
we can hear you.
Yeah, we
Yeah,
can
if
hear
you
you.
proceed with the presentation. Yeah, I'd prefer to
Yeah.
present my own presentation, sir, not the video.
Okay,
If
so
I,
you will. Okay, go ahead.
so allow me to share my screen again. I'm sorry for the inconvenience.
No
I'll
problem.
try.
Please carry on,
It's
ma'am.
my first time using this. Okay, so can you see my presentation now?
Yeah.
We can see your
Okay,
presentation.
so good afternoon from the Philippines. I'm very sorry if you will hear some kind of creepy sound because I'm at home right now and we cannot prevent our neighbors to create some noise. So please bear with me in the next 10 minutes. So I will be presenting research output which is entitled A Biochar from Corn Waste as a Purifier in a Recirculating Aquaculture Systems. So basically for Nile tilapia production as a test, but we're trying to expand it further. So why we focus on this? Oh no. The problem now is, okay. So just to give you a brief background of the project, we all know that here in the Philippines, corn cobs and stalks is waste from the cultivation of corn. So generally, both of waste disposed and it is not utilized. The costly of energy prices, solution to problems of waste, and increased value added by utilization of this waste are the driving forces for the utilization of these corn cobs to other applications. So we have to look for the other possible applications of these corn cobs. So, but definitely it is very timely because that the title of the conference is for sustainable waste management. So we focus on corn cobs. Why do we choose that? And why do we choose the tilapia production as a test fish or crop? So with the growing number of human population through the years, the demand for food increases. So which entails higher food production for human consumption. Then here in the Philippines, tilapia is the most consumed farmed fish with an average of yearly consumption of 4.6 kilograms per person. Yet, the tilapia farming sector has declined by 30% in the last 8 years. As you all know, due to some environmental problems, the shortage of the area where we can grow tilapia. So basically, if 4.6 kilograms per person was the need, we need 500,480 metric tons of fish to be able to feed each. So also, additional fish farming technologies were added through the traditional pond system to be able to meet higher demand for fish. So this includes the semi-intensive systems and intensive production systems, such as the production in fish tanks and fish cages. So intensive production includes the use of the RAS or the recirculating aquaculture systems. Because one of its advantages is its ability to support extremely high stocking densities and high net production with limited volume of water requirements. However, high stocking density will result in high fish wastes, which are toxic ammonia compounds in the form of an ionized ammonia excreted into the water and uneaten feed particles that needs to be removed. So those wastes uh, will become harmful for the fish or for the growth of the fish. So just to give you another supporting study, a study by Sichula showed that the ammonia concentration in the treatment tanks reduced significantly with the application of biochar from corn cobs with increase in culture time. So definitely somebody from India also studied this, yet we tried and tested it here in the Philippines. So this significant negative correlation between the concentration of ammonia in water and the time after the application of the activated carbon is an indication that ammonia was being removed from the water by adsorption. So the properties of biochar has some similarities with those of the properties of the activated carbon. But however, there has been limited researches on the potential of this biochar to improve the quality of aquaculture water in RAS for fish production here in the Philippines. That is why we were able to come up with this idea. So the objective is to enhance the TAN or the total ammonia nitrogen and ionized ammonia levels using biochar from corn cobs in a recirculating aquaculture system. So we specifically it aimed to devise a biochar filtration system for RAS, evaluates its water quality parameters, and evaluate the adsorption capacity of biochar from corn cobs in terms only of TAN and an ionized ammonia. So what we did, for the input, we collected corn cobs from all over the province, Pangasinan and Tarlac. So we were able to carbonize this corn cobs for us to produce this. And then to be able to attain the uniform size, which is 5 to 10 millimeter, we crush it and sieve these samples. And then after that, the output will be like this, the carbonized biochar with uniform sizes. Ayan. So we weigh it. Then another input is designing a biochar filtration tank wherein we can put our biochar samples. Then we were able to design also this whole setup composing of the filtration tank, the fish tank, pump for the recirculating the water, and additional two filters, which is the sludge and the sediment filter. So these two filters removed other particles aside from like the sludge and the slurries and also sediments. Then we fabricated it and we come up with this setup or this system or the prototype of the system. Then next, this system, we tried to test it. So the water was filled with 1,000 or 1 cubic meter filled with water. Then we tried to determine its water quality or the water data. And for the output, we were able to come up with the different water quality parameters such as the water temperature, its pH, the dissolved oxygen, the TAN, and an ionized ammonia, which are the some of the water quality parameters important for the growth of the fish. So lastly, to be able to determine if the fish or the Nile tilapia will survive in that system, so we tested it for 1 month and we observed the different water quality parameters. So this is the closer look or the clearer view of the system. And the operation, so as you can see, we have the two filter. This is the sludge and the sediment filter. And here the FGHKNN, this is where the biochar from corn cobs were placed. So the first filtration system wherein the water will pump out from the tank going to the first for the first filter, then going up here to the biochar filtration system, then moving down the sediment filter, because after passing through this biochar filtration system, the color of the water will turn dark gray to black. So we have to remove that color to be able uh, to maintain its quality and its appearance. So sometimes when we see black color, maybe we can identify that it is not possible to live with. So here are some of the water quality parameters in tanks, and we compare it without the biochar filtration. So as you can see, although there is kind of significant difference, but it shows that the use of the system totally or improve the water quality. So as you can see here, the green one with biochar filtration, the green lines indicates that the water or the TAN level in the system was stabilizes and were just between 0 to 5 ppm. Wherein without the biochar filtration, continuously as the number of days improve, the TAN level also increases. So the same with the unionized ammonia reduction. If you can see with biochar filtration, it is just between 0 to 2 ppm. So we were able to neutralize and limit the unionized ammonia level. So using the three filters, we try to observe its behavior for 8 hours. Then we also perform a simple cost analysis of the design system. And the total cost is only 10,878 pesos. And given the capacity of 150 pieces per cycle, although the ROI is 1.74 years, if we were able to develop or have more setup, we can come up with a shorter ROI. Then in conclusion, the potential of biochar filtration for the enhancement of TAN and unionized ammonia levels in RAS was determined. So based on the result of the study, it can be concluded that the device biochar filtration system were able to enhance the quality of aquaculture water, specifically the RAS, the TAN, and the unionized ammonia. So it revealed that the average water temperature between the two experimental tanks was not significantly different with each others. So hence, the pH, the DO, TAN, and ionized ammonia revealed a significant difference, but it is tolerable. Then the biochar filtration system, so this is the main highlight of the study, successfully reduced the level of TAN at a rate of 0.56 parts per million per hour for every 1 kilogram of biochar from corn cobs, and 0.72 ppm per hour for the reduction of the unionized ammonia tested in a 1 cubic meter fish tank under the system. So I would like to thank the OST, ERDT, Tarlac Agricultural University, and my colleagues for the completion of this study. So that's all. Thank you.
Thank you, Dr. Puello, for that wonderful presentation. Okay, moving forward, we now go to paper number 8, AB 252. The title is The Effectiveness of Kawayang Tinik, Bambusa brumiana for Climate Change Mitigation, Carbon Sequestration, and Livelihood Potential in Ocampo, Camarines Sur. The authors are Celerino B. Liesol Jr., Aris O. Otibo, and B. Foronda from the Philippines. Take it away.
Good morning, good afternoon, good evening to everyone. I am Dr. Celerino Bigliasol, the author of this study. The effectiveness of Kawayang Hinik, Bambusa blumiana as a climate change mitigation, carbon sequestration, and livelihood potentials in Ocampo, Camarines Sur, Philippines. A study which was conducted in the Philippines at Ocampo. So we know very well that bamboo is associated with many forms of arts and culture in the Philippines, technology, environment, farming, and livelihood, and so many things. Thus, bamboo is a multiple use and provide multidimensional benefits to the society. It has been associated to 1,000 of uses from household implements, materials for building houses, to food and paper, and now on intensified livelihood and industry technologies, and more importantly, bamboo is a crop which is dubbed as a resilient crop used for phytoremediation, climate change impact mitigation, and an efficient carbon sequestration. So because of its multiple uses, bamboo is now being regarded as the most resilient crop, and it captures a great importance and attention to our Quest Sustainable Development Goal, thus promoted in most cases as the resilient and profitable crop in agriculture, forestry, livelihood industry. And in the Philippines, bamboo is a potential plant for building the environment back better. Thus, the premises why this study was undertaken. So the objective of the study is to determine the effect of Bambusa blumiana on the observed climate or microclimate conditions of the farm, with open grass and rice land as control, and do determine the sequestration capacity of 1 hectare Bambusa blumiana plantation, and assess the financial viability as a livelihood in peripheral communities of the municipality. So the study was conducted in a 1 hectare plantation. The effect of Bambusa blumiana on microclimate condition was made through a series of monitoring and periodic evaluation in a span of 3 years, from 2016 to 2019. The changes in temperature was determined by monitoring the temperature prevailing in the 3 sites, namely grassland, riceland, and the Bambusa blumiana plantation, which were located in the nearby sites. The sequestration capacity of 1 hectare was also determined to the use of microbiological formula. Lastly, a survey among selected stakeholders was conducted to determine the cost and return on the bamboo from among the selected processors and traders. Thereby, bamboo-based livelihood and profitability of 1 hectare bamboo plantation were described. So look at the site. These are the 3 sites from where Bambusa blumiana plantation was. The figure 1 shows the grassland ecosystem. The second figure shows the riceland ecosystem, and the third shows the Bambusa blumiana plantation under study. So these are the 3 sites where the study was located and compared to its microclimate conditions. So the results of the study shows that the effect of Bambusa blumiana on the observed microclimate condition of the farm is a significant reduction of temperature to an average ranging 25 to 30%, and 50 to 30% compared with open grassland and riceland, effectively. So the effect of Bambusa blumiana on the observed microclimate shows in the figure 4. So the average temperature shows that there is an apparent decrease in the temperature as compared with the 2 ecosystem, the riceland. So indeed, there was a change in the temperature, lowered by about 25%. So the table 1 also describes the temperature changes, the difference of which is ranging from 13 to 2% to 55%. But the maximum difference that was in a series of data was 60%. So the difference of open grassland and Bambusa shows that there is a 9.6 for year 1, 29.3 for year 2, year 3, and 34 for year 4, in an average of 22.9%. Okay. So on carbon sequestration, the sequestration potential of 1 hectare Bambusa blumiana plantation was found to generate from 1.9 to 2.3 tons of carbon per year. So table below shows the series of carbon sequestration generation from a 1 hectare Bambusa blumiana from 2016 to 2018. it was noted that the initial year, after 1 year of Bamboo Lumniana, the plantation could generate 0.2 tons of carbon and a yearly increment of 60% increase in the second year with 0.5 tons and 54.5% with a 1.1 tons after 2 years and 42.1% with 1.9 tons in the fourth year. So the data indicate that Bambusa Lumniana exhibit a fast-growing species based on the amount of herbage it could produce. So look at the graph. The graph shows here the trajectory of different carbon sequestration which was taken year 1, year 2, year 3, year 4. So the grand mean is 1.3. So the natural thickets of the canopy of bambusa could influence the reduction of microclimate temperature that cool itself surrounding as fast as leaves formation after typhoon and harvest could make it significantly cover of the plants of the shortest period. This was observed during wet season in the Philippines. The wet season in the Philippines is commencing on July to December. So in figure 6 to 13 below shows the thickets of canopies that could be shown among our listeners, among our audiences, the types of bamboo thickets. So first is the panoramic view of the bambusa plantation taken from the highway. So this is the panoramic view. It commences almost 100 to 150 kilometers, meters, I mean. So a 4-year-old bambusa, this shows the figure in 7. Another is yung figure 8, which shows the basal area of one bamboo clump. And we have also the figure 9, another clump of bamboo, which is about 4 years. And another clump of bambusa showing the spacing density of 8 by 8 meters. And this one is taking the temperature view of the internal footage of the bambusa plantation. And another is the second, and the figure 12 and 13 shows the difference between the two. This one is the footage while taken in the afternoon. So it seems that the temperature is cooler than in the mid. This one is in the mid noon or noon. This one is in the late afternoon. So in terms of viability of 1 hectare Bambusa Lumniana plantation, the financial viability of bambusa was derived through a survey with farmers, industry, and traders of various products that were produced in the locality. So the multifarious products that were derived varies from planting materials to bamboo comes sold as raw materials from various purposes such as farm crops, household fuel. So figure 8 shows the different types of products which was produced and currently being marketed. So in the form of different sizes, we have the bamboo cams which price 150 per piece. We have a splitted clean bamboo per bundle, which has a dimension of 8 feet, 10 feet to 16 feet, which has a price of 18 to 150. Then we also have bamboo fuel bundle, which is priced to 30 per piece per bundle containing 20. Planting materials 70 to 100. Bamboo shoots, which is sold per kilogram, and barbecue sticks with that. So let's look at the different products. So these are the bamboo cams, the dry bamboo, the bamboo shoots, the splitted bamboo, the bahay kubo. So bamboo and barbecue sticks, which are also part of the, and the engineered processed bamboo here, which is a potential product in the Philippines, in other Asian countries. Okay. Courtesy of our Google Drive. So for the value of the product, it was noted that the value chain starts from farmers, processor industry, and middleman. So all these things contributes to the value adding of different bamboo products, which originated from farmer, processor, industry, traders, and household. So all these things contributed to the profitability and sustainability of bamboo products. So in terms of financial profitability of 1 hectare bambusa, the rate of return on investment or ROI, which provide a positive profit, was realized in the 4th year of production with an initial rate of 2.7 and continue to increase at an increasing rate of 9.7, 11.5, 15, and 19, and 27, and 36 for the year 5, 6, 7, 8 as forecasted. So in table 2, it shows that the cost and return analysis shows a positive in for year 2.7. So in order to end up this, the researcher have this concluding remarks about the study. Bamboo has continuously provided benefits among populace. Venturing bamboo production in the country is still not so intense because of its limited space, technologies, and sufficient capital that a private could utilize and indulge. So Filipinos are well known from their ingenuity and creativity and merely have ability to design, develop, and produce novel bamboo applications for local markets for export. However, lack of capital to venture enterprise is one thing. So small-scale industry must be accorded with more technical support to scale up product development instead of capital. Bamboo is indeed highly ecologically, socially, economically viable and lucrative commodity to venture since time immemorial. Intensified bamboo production, utilization, and conservation for balancing ecosystem, climate change impact mitigation, and its associated livelihood, entrepreneur in the Philippines, and in related socio-biophysical and cultural setting is highly recommended for sustainable development. To be able to tap the existing potential for development of bamboo sector, it will be necessary for the public and private sector to recognize that bamboo is an important and highly valuable commodity and not merely a minor non-forest product. For the governments and non-government organizations concerned to pay adequate attention to the development and management of bamboo resources. Development plans for enhancing bamboo production and utilization should be formulated. The speed of replenishing the resources base should be increased and supporting farmers in rehabilitating their forests. Thank you so much. Good luck and good health.
Thank you very much, Dr. Liesol Jr. for a very nice presentation. Okay, moving forward to our next speaker, AB 273. The title is Current Status of E-Waste in the Philippines. This will be presented by Linley Pintor from the ERDB.
Greetings from the Philippines. Let me share with you all the current status of e-waste in the Philippines, together with my co-author, no other than Dr. Arturo Mariano Figueroa. It is sad to note that in the Philippines, there is lack of formal comprehensive e-waste management system. In fact, there are pending legislations, such as the guidelines on the environmentally sound management of waste, electrical, and electronic equipment, Senate Bill number 568, referring to the E-Waste and Cellular Phone Recycling Act, and House Bill number 5901 that pertains to E-Waste Management Act. We know for a fact that e-waste contains hazardous materials, which is not good for our health. The global problem is there is an increasing number of technological device users. In 2018, it is recorded that 50 million metric tons of e-waste worldwide, and by 2021, this year, the amount is expected to increase by 52 million metric tons. Are different sources of waste from electrical and electronic equipment generation. The first one is the corporate and household, of which the nature focus on household appliances, ICT equipment, and consumer electronics, followed by international trade, of which the use and scrap electrical and electronic parts assemblies, photocopying equipment, scrap printed wiring, toward printed circuit board. And from this slide, you can see this estimation in terms of the corporate and household and international trade. In terms of material recovery process, this includes the sorting or disassembly pertaining to the manual dismantling, which is considered as informal, and crushing, referring to the mechanical crushing and manual crushing, while the process of separation is locally done and the thermal treatment is likewise locally done. All right. In the next slide, you can see that there are only a few e-waste recycling centers in the Philippines. So there is really a need to increase the number of e-waste recycling in order to address the problem. Moving on, there are actually limited studies conducted on e-waste in the Philippines. In 2019, the study focused on the e-waste common types and characteristics and the e-waste recoverable electronic components. In 2018, the study focused on e-waste management and impact to human health and the environment, while the study conducted in 2017 pertains to electrical waste management practices at the university level. So you can see the different methodology employed by the various researchers. And then there was also a study conducted in 2017. There are two studies focusing on the perception and practices of undergraduate studies on electronic waste, and they identified the management practices. Another one estimate the waste of mobile phones using the neural networks, of which the methodology focus on neural networks and also configuration, neural network software estimation, and the conduct of survey. And then in 2016, the study focused on the management of e-waste generated by the disposal of personal, corporate, computers, laptop, and also cellular phones. Moving on, another study conducted in 2016 focused on the recycling processes of CRT TV monitors, the process flow, and informal recycling sites. And then another one in 2016, of which the researchers evaluate the policies and practices on electronic waste management in selected universities in the Philippines. Further, evaluate the e-waste management practices at the university system, of which the different authors likewise have similarities and differences in terms of the methodology. And in 2015, the study focused on identifying the recovery process and evaluated the layout of the recycling site and valuable substances in the site, of which they employed survey and literature review. And then two studies in 2014 referring to documenting the problems on e-waste recycling practices, and likewise the management tool and decision making for the evaluation of e-waste management system. In the study in 2014, the first one pertains to narrative interview, while the second one, they employed AHP SWOT and key informant interview. And then in 2010, the study focused on e-waste on ICT waste based from review of literatures and interview, while in 2009, this focused on policy gap and e-waste management measurement. And then in 2005, the researchers estimated the current and future quantity of e-waste. So there are different sectors in the country focusing on e-waste management. The first one, referring to the environment, the DENR, EMB, and the local government units, of which the approaches focus on Republic Act 9003, or the Ecological Solid Waste Management Act of 2000, classifying electronic waste under special waste. This Republic Act specifies that the collection of non-recyclable materials and special waste shall be the responsibility of the municipality or city. And then another one, also in the environment, that the lead agencies are is the DENR, particularly the Environmental Management Bureau. This refers to the National Government Development Guidelines on the environmental management of waste, electrical, and electronic equipment. And then the lead agency is the Eco Waste Coalition. In terms of health and safety, this is a public interest environmental group of launched because of their e-waste program that introduced public awareness and trust posed by electronic waste in human health. The Globe Telecom, this is a producer of mobile phones in the country, they have a project called the Project One Phone. It is a mobile recycling program by Globe focusing on recovering and recycling electronic waste, specifically the mobile phones and portable devices such as tablets. And then the e-waste management of Philippines, their approach is e-waste. This one established in 1995. It's a door-to-door operation that collects used gadgets that are live for proper disposal. And then we have the EnviroCycle Philippines Incorporated that handles any type of electronic disposable from phones to computers to LED and batteries. All right, moving on to the next slide. There are actually plans and targets by the Philippine government, particularly the implementation of PCB management programs for electric cooperatives and safe e-waste management. This aims to eliminate 600 metric tons of PCB contaminated oil and equipment and 1,150 hazardous waste for the benefit of the global community, which aim to achieve the following project objectives. First is strengthen legislation and institutional capacity in implementing action plan and reduction and eventual elimination of hazardous waste releases from waste electronic and electrical equipment in order to mitigate health impact. Moving on, the PCB management plans in terms of electric cooperatives, in terms of effective implementation, increase capacity for and awareness on sustainable and effective WEE and hazardous waste management by relevant sectors. The project and its stakeholders are able to monitor and evaluate the project's progress, allowing for the implementation of the national plans on POPs. In the next slide, after reviewing literatures with my co-author, we can therefore conclude that we are not getting participation of stakeholders in designing electrical and electronic products in e-waste recycling that are So we therefore recommend strong information, education, and communication activities be conducted by the local government units in order to achieve high level of awareness and knowledge among the households, business establishments, and industries. Through the IEC, the local government units can elicit the participation of the different sectors in the community. And because of limited studies, there is really a need to conduct more studies on e-waste in order to address research gaps.
Thank you. Thank you very much, Dr. Pintor, for a very nice presentation. Then moving forward, we have paper number 10, AB 328. The title is Design, Construction, and Evaluation of Biogas System Utilizing Market Bio Waste. Rochelle Sena, are you ready?
Yes, we have it.
Okay, very good.
Good day and mabuhay from the Philippines. I am Rochelle Sena, an agricultural and biosystems engineer from Central Bicol State University of Agriculture. On behalf of my advisor and co-researcher, Engineer Jennifer M. Ebanya, I will be presenting our research about the design, construction, and evaluation of a biogas system utilizing market biowaste. Most natural gas deposits lie deep under the Earth's surface and were covered by many layers of soil and rock, and are predominantly made up of between 75 to 99% methane, a small proportion of heavy elements like ethane, propane, butane, and ethylene. So in order to generate natural gas, reservoirs must be discovered and extracted before natural gas can be supplied to consumers, and this requires a great deal of effort and investment. Meanwhile, there are municipal solid waste or MSW coming from residential, commercial, institutional, and industrial sources. And the typical bio-waste consists of kitchen waste or food waste and yard or garden waste. However, not all municipalities in the country have waste disposal areas or sanitary landfills. Burning, open pit disposals, and throwing of garbage in vacant spaces, even into waterways, remain as the traditional method of waste disposal being used. In order to create a more effective and efficient solid waste management, market biowaste can be efficiently managed instead of immediate disposal and be an alternative source of energy, therefore reducing the cost of purchasing gas. Thus, this study aimed to determine and construct a system that generates biogas from market biowaste, to determine and analyze the effectiveness and efficiency of generating biogas from market biowaste, and lastly, to determine the economic viability of the system. Significance of the study. The development of a system that generates biogas from market biowaste can benefit those people in the household and even in food establishments. In this way, market biowaste can be managed efficiently by being able to create another useful product as well as reduce the volume of waste to be disposed to the environment. The materials used for construction, as shown from left to right, are 100-liter drum container, pipes, PVC clean out, PVC orange elbow, S-lone blue T, S-lone blue elbow, male and female adapter. Other materials used for construction are sealant, marine epoxy, PVC ball valve, Teflon tape, brass two-way splitter, brass ball valve, hose pumps, and end cap. So the construction of the biogas system was based on the completed design as shown. In the construction of the biogas system, the design served as a guide. The construction of the biogas system includes assembly of the inlet and outlet pipes and stirrer and punching of holes on the drum containers where these pipes shall be inserted. The slurry outlet pipe was inserted on the hole on the side of the drum container, while the inlet pipe, gas outlet, and stirrer were inserted on the holes on the lid of the container. And with the help of our fabricator and also a biogas energy advocate, Mr. Junrey Paracueles, the digesters were made sure to be sealed and free from leaks. And the final output was two setups of 100 liters biogas digesters. The biogas systems were placed in a semi-shaded area close to where the raw materials were available and where biogas in sludge were used and stored. And for the major parts and components of the biogas system, these are the stator and inlet pipe, the outlet pipe, biogas outlet, biogas hose, biogas chamber or storage, and the thermohygrometer to measure the temperature inside the digester. Study area or location. The study was conducted at the back of our residential area, which is about 45 meters away from Villa Grande Homes Satellite Market, which is the source of the waste materials. The biogas system was set up on a clear semi-shaded area to protect the system from the intensity of sunlight. A protective tarpaulin covering was utilized as roofing. The site also has a stable soil foundation, but to ensure that there will be no tree roots intrusions, the systems were placed on a firm mounting. The materials used for evaluation, as shown from left to right, are the bioinoculants from the Naga City Solid Waste Management Office, food and fruit waste, vegetable waste, fish waste, and the dechlorinated water. Preparing the waste materials includes chopping them into smaller pieces for faster decomposition. The two setups of the biogas systems have different waste utilization ratio of fruits and vegetable to food, to fish, to water. Setup A follows 1:1:1:3, while setup B follows 1:1:2:4. The total digester volume is 100 liters, wherein 80% of which is the total slurry volume and 20% is for freeboard. The total slurry volume is 90% waste to water volume and 10% bioinoculants. Waste and water has ratio 1:1. The evaluation of the biogas systems includes measuring or weighing the slurry, loading or feeding the slurry through the inlet pipe on the digesters, daily checking of temperature inside the digester, checking for presence of leaks, and other troubleshooting. So the checking of the temperature and the checking for presence of leaks and other troubleshooting was also included for the operation and maintenance of the biogas systems. The digester inside temperatures met the standard of 20 to 40 degrees Celsius. Meanwhile, the volume of biogas daily produced by setup A averaged 0.004 to 0.005 cubic meters, and setup B 0.0055 to 0.0725 cubic meters. The biogas volume was also measured using urine bags, which are graduated with units of measurement of volume. So these are the photos of the produced bags in the urine bags. Produced biogas in the urine bags, rather. So after the introduction of flame to the biogas, the produced biogas was able to successfully sustain the flame. And using the cost and return analysis of a biogas production compared to the usage of liquefied petroleum gas or the LPG, using LPG will cost 6,780 pesos or 134 US dollars, but no return and income. However, using biogas technology, it will only cost 1,726 0.725 pesos or 34 US dollars. And through sales of the produced biogas and slurry, one can gain net income of 3,143 pesos and 805 centavos to 3,170.275 pesos or 63 US dollars. As for the payback period, for biogas setup A, it's 4 months and 10 days, while the payback period for setup B is 4 months and 9 days. Based on the results of the study, the following conclusions were drawn as per objectives. Number 1, the designed biogas systems A and B were constructed. The biogas systems were evaluated by using the market biowaste generated from the near satellite market. Number 2, the setups were considered effective, operating on mesophilic digestion following the standard temperature of 20 to 40 degrees Celsius. Functioning as it was designed, setup A was able to produce biogas 56 days after feeding with 0.00405 to 0.005 cubic meters per day, and setup B was able to produce biogas 46 days after feeding at 0.005 to 0.00725 cubic meters per day. And the cost for investment or the cost of investment for a unit of biogas system utilizing market biowaste was 1,726 pesos and 725 centavos or equivalent to 34 US dollars. It was calculated that there is net income of 3,143 pesos and 805 centavos in operating a unit of setup A, while 3,170 pesos 275 centavos in setup B. The payback period for each setups shall be within 4 months and 9 to 10 days. Thus, the two setups of biogas systems were found to be economically viable. For the recommendations based from the foregoing statements, the following recommendations were made. If commercially available, one may use a mini biogas pressure gauge ranging 0 to 2 psi to determine pressure of the biogas system to ensure accurate data. Volume of gas produced can be computed from the data about the pressure inside the digester. The study used the biogas or the bioinoculant from the Naga City Solid Waste Management Office, consisting of combinations of aerobic, anaerobic, and microphilic bacteria. If possible, to determine, utilize bioinoculants that are mesophilic and anaerobic to meet the standard temperature throughout operations and to enhance breaking down activity. If market biowaste is still to be utilized, redesign to larger capacity of digesters utilizing more amount of waste and monitored loading to produce larger amount of gas production. And fish waste have great potential as a source of high-valued organic carbon for methane production, but also have limitation like the high content of ammonia nitrogen. So anaerobic treatment of fish waste is possible with co-digestion. So that's according to Tomzak, Wanzel, and Levlin on their write-up about biogas production from fish waste in cold digestions with sewage sludge. Since market biowaste are mainly carbon-rich, it is recommended to use nitrogen source co-digestion like the digested sludge, cow dung, or pig manure. Consider biogas characterization using available technologies such as gas chromatography to determine the exact components of the produced biogas. And last recommendation is that the site should be properly roofed to protect the system from direct sunlight, UV rays, and bad weather. So at this point, I would like to thank my advisor and co-researcher, Engineer Jennifer Ebonia, and the Central Bicol State University of Agriculture for supporting us to share this study in this international conference on sustainable waste management and circular economy and IPLA Global Forum. I will be ending this presentation by saying that there is sustainability through biogas technology. Again, this is Rochelle Sena, an agricultural and biosystems engineer, saying good day and mabuhay from the Philippines.
Okay, thank you very much, Rochelle, for that very nice presentation. I think that's we have finished all the Philippine papers, unless paper number 5 is around. Last call for paper number 5. Are you there? Although we have no more time, actually, we have consumed the time allotted for us for paper presentation. Number 5 is
Yeah,
Maria
exactly,
Aguilar.
sir. Yeah, exactly. We are delaying our time. We have to complete within the 2:30 of Indian Standard Time, but we are lagging for 10 minutes. So no
Yeah,
problem, sir. You just conclude with your chair summary.
okay,
And yeah,
okay,
and I
okay.
will request all the participants, if you have any question, please write to the chat box so that our chair can take the questions to the respective speakers.
Okay, so to close this session, I will just put down my summary. As a summary of this Philippine special session, the researchers from the Philippines were able to present a wide range of topics ranging from waste recycling, that is a concrete hollow block from plastic, biofilter from charred corn, and biogas. And then they discuss also climate change impact studies. And then they also analyzed pollution mitigation flow. And then finally, they presented an e-waste management, e-waste status. All the topics presented by the Philippines reflect the Philippine effort towards supporting sustainability and circular economy. Again, let me say my heartfelt thanks to the organizer of the IconSWM 11 and headed by our professor and friend, Professor Goss. Thank you very much.
Request you, sir, to kindly write the chair summary in the respective mail ID, and please send us the writing sheet which has been provided to you. And I'm just writing the mail ID, the respective mail ID, when you have to send. Yeah?
Okay, so it is officially closed now, the Philippine session. Are we waiting for a final say from Dr. Goss? No more?
Yeah. I'm waiting for sir. Just kindly wait a few seconds. Give me a couple of minutes. He will be here. And I request all the participants to kindly turn on your camera so that we can see your faces and take a photograph. Please. Sir is here.
No, sure, no, sure. Hi. Hi, Figueroa.
Yes, Dr. Goss.
So I'm very happy that most of the speakers are here today in this Philippine session.
Yes.
However, I believe that Professor Naperi could not join in the morning, right?
Yes.
Yeah. So, however, he will be joining in the valedictory session on the 4th. I just invited him. I am very happy seeing all my friends from Philippines after nearly 1 year, because last year in 2020, I could see most of the faces from Philippines and presenting their papers. And I mean, I have seen all the abstract which were sent. It is really very rich. And I'm proud that there are excellent work which are being carried out in different universities in Philippines, specifically the University of Aris, where he is working, and he had a very good leadership, their president. And I can see my good friend Eckhart Kraft from Germany. Hi. So, you know that both of us went together in the Sundarban River, and we spent 3 days on the boat, expecting to see tiger, but ultimately we could see a lot of deer and others, but no tiger. But we could see the print of tiger. So, uh, you know that Philippines, there are lot of scopes for waste management. My friend Visu from Thailand, he will agree. He is taking tea without us. He is not sharing tea with us. So you know that I visited Philippines a number of times. I could visit number of barangay where they are collecting dry waste, and the small families, they are making their livelihood earning by selling all those dry waste. I have also seen the very big dump yard which had a big accident in your city, and I have seen the waste to energy, that biogas plant. Then there are number of social work which was created. Like say, I have seen people, the ladies were involved in stitching different garments. They were given the stitching machine, and their kids were studying just in a chamber beside that. So this type of community involvement and social work which goes side by side in Philippines. So I believe that the research of the people from Philippines will be strengthening the waste management and circular economy implementation, and that will not help only the Philippines, but it will help the global movement which are being carried out by different researchers throughout the world. I'm happy that many of our friends around friends from 47 countries joined this conference. It is growing with the help of you. We have, as of now, 41 working group, country-specific working group who are working in collaboration with different countries and the IconSWM. And once again, I thank all the participants, all the speakers who are helping in enriching this conference in a bigger way. And specifically for this session, I must thank Professor Figueroa. You know that we met in Jeju Island in 2019, and I gave him a word, valorization. We are just discussing, and still today he is my valorization friend. And that was a new word to him because he's an electrical engineer. And I call him sometime my valorization friend. He's very active, though he has retired from his service, regular service. He's very active, and I wish that he will give a good drive to make all others active in Philippines in waste management and circular economy activity. With this, I must thank once again to all of you, and I'm handing over the microphone to Chair once again. But meantime, I'll request Dr. Professor Visu and Eckhart to say a few words, please. And I request all of you to open your camera so that my secretariat can take a photograph. Over to Visu first. Microphone.
Thank you, Professor Ghosh. It was nice listening to this afternoon session. Very rich and different presentation from Philippines. I really enjoyed it. It's a different format. Thank you very much. We're looking forward to the remaining few days on this conference. Once again, thanks a lot.
Thank you.
Listen to Eckhart.
Yeah, Eckhart. Over to Eckhart.
Yeah. I should say good morning, everybody. Since in Germany we still have the morning, it's before lunch.
Yeah.
So thank you very much. My best regards to all of you. Southeast Asia, I think it has been a very interesting session. Nevertheless, that I just joined the second part of it. I'm so sorry for that. And as I see the whole program of that conference, it is strongly growing, and I'm deeply impressed from the view of the organizers as well as from the participants, bringing their ideas and not looking just for the ideas of others, but trying hard to find self-solutions, own solutions. And I think that is the way forward, to exchange really the local solutions to be adopted in regional areas. So thank you so much. And I'll be with you at least till the afternoon European time. Professor Gosh, thanks so much. And we have been on the board, you're right, but
Yes.
it has been after the conference in the Kuwait University in Bangladesh. So the others think we are just on vacation, but that is not true. We've been on vacation for a 2 days, 3 days trip after a scientific conference on waste management, the topic of today. Thank you.
Sure.
Thank you.
Thank you. Yeah, and one more thing I like to highlight here, that we have two lifetime achievement awardees here. One is Professor Bisu. He received it in 2020, and this year I can see Mr. Diviz Rao, M. Diviz Rao. He is also present here. Mr. Rao. Mr. Rao, Diviz Rao, I can see your name. All right, maybe he is having some problem. So over to Professor Figueroa for your conclusion. What? Professor Figueroa.
Yes.
Over to you. Yeah. You can now conclude. You
Yeah.
are the king of this session.
I therefore close the door now for the special Philippine session. Congratulations to all researchers from the Philippines. Okay. Okay, bye-bye.
Bye-bye.
Next session will start at 3:15. So please come back again with some tiffin. Thank you very much. Bye-bye. Aris, bye-bye.
Bye, Doc Gosh. Bye.
Bye.
Thank you, everyone.
Thank you.